Well, hello and welcome to Nani Notes. I'm back from retirement for a year, and look what happened in my school district. That's the Anchorage School District. We've changed textbooks. We are now using the McGraw Hill. This is all new to me. Well, I guess it's all new to a lot of us. So, won't waste any more time. We'll just get into it. This video is, I guess, for the students who missed some time and maybe they kind of missed the connection that they could have made in class. So I'm not going to show you how to do everything, but we're going to start here. Well, the first one in this series, lesson 1.2, constructing patterns. Now, just the practice part. That's the part that you're supposed to do at the end with a little guidance from your teacher. Well, if you were absent, here's your guidance. So, let's just get to it. And ready? Okay, let's go. Now let's move up to this. Describe the procedure used to construct this diagram. Now again, this is a construction. So, oh my gosh, we've been using that compass and straight edge. And, let's go through it. But can we put it to words? And this was your task. You were supposed to describe how would you tell somebody to do this? Well, maybe I'd start with one step. I'd start by drawing A and B. Two random points just floating around in this plane. Then, pick up my compass, and you know what you do. You put the needle on A. Gosh, we've been doing this. We're going to gap it to B, so we get a nice dynamic swing there, and we'll go all the way around and make ourselves a beautiful circle. Oh, so much fun. And the circle right there. Then maybe you would describe our next step. Let's construct circle B. That's circle centered at B, passing through A. And I'm going to, again, I flip my compass over. I'm going to gap it to A. This can be done, well, this is a pure Euclidean construction. This is okay with a collapsible compass, as you can reset the gap from A to B, B to A. And now we've got two circles. Two circles, maybe the third thing we're going to do is identify the points of intersections of the two circles. They're going to meet in exactly two places. And finally, we'll use our straight edge, Sammy straight edge, and we're going to connect C and D. And remember, when we did this in class, we said we lay that straight edge down and we go through. Don't stop there, because this one isn't really a perpendicular bisector, but it's the same construction. We're going to go through because we get a nice clean read on it like that. So go ahead and check that out. All right, let's look at the next one. I think this is on. Oh boy, the circles are centered at A and B. Similar diagram. And we want to know which are true. Now, if I look at this, I'm just going to show you this little radius here. AB, well, that's the radius of the circle centered at A. Well, this looks like this is also that radius, as is this. I could swing all the way around, and so is AE. Now the notation I'm using right here, the lowercase m, that stands for the measure of the segment. In this case, AB is equal to the measure of the segment AC. So in this case, AB, if they are congruent, they have the same measure. So I could say it several ways. I could say the measure of AB is equal to the measure of AC, or I could actually just type it this way. AB is equal to AC. That has the same meaning. Now, maybe I said, oh, wait a minute, AB, I could also say this segment is AB. If I swing it this way, And this way, I'm going to see more congruent segments. Hey, that's kind of fun. So it looks like we've got a bunch of congruent segments. I'll let you identify them. But that's what you're after in this exercise. Right? Let's try out number 3. Nope, 3. I guess if 3 is up here. Select all the lines that must have the same length as AB. Well, again, AB is over here. This is AB. That looks like the same distance there. I'm okay with that. Now the other ones, do we know if they're longer or shorter? You might say CD looks shorter than AC, but is it? We don't really know. We're not given that much information. I mean, really, this is the same diagram. So the only thing we could come up with are we've got 2 radii of the circle with its center at A. And you know what they are. Okay, last one. I think it's the last one. Oh, okay. You know, this one, when I was reading this new book, there's something a little different here from the McDougal Littel, and that is that the author is going to that idea of taking an instrument. If the measure of AB is the radius of the circle at C, so go ahead and you're gapping that compass. Imagine that. And you're moving it over there. Whoops. I traced that point over there. And then you're replicating a circle. You're just copying that circle. Now, if AB, the measure of AB, is the radius of AC, and you've got this diagram, you get this compass out of the way, then what do we know? And you'll see the different notation here. We say AB, what it really stands for is the distance between the point A and point B, which is the same as the measure of the segment with endpoints A and B. So is AB the same as CD? You decide. How about AB and CE? AB, CF, AB, and EF. I think you'll see there's only one answer that makes any sense. And I think we're done. That was pretty quick. There you go. So that's 4. This was number 3. And on the previous page, page 13, we have this diagram. And you had this. So easy squeezy. Put that in your notes, and we'll see you in class. Thank you for watching 90 Notes.